this lesson, you're going to learn how to solve one-step equations. Please make sure you take notes in your interactive notebook on the page that I tell you in class. Remember, you can always pause at any time if you need to get more information down in your interactive notebook. When solving one-step equations, it's good to first of all know what an equation is. An equation shows two quantities are equal. And it usually has some type of variable involved. If it doesn't have a variable, then you're looking more at a numerical sentence rather than an algebraic equation. Now, in order to solve, you're going to want to find the value of the variable that makes the equation true. Once you solve and get the solution is going to be the value of the variable that makes the equation true. Now, in order to solve these one-step equations, we're going to have to use what's called inverse operations. Now, we have kind of talked about this before in class at the beginning of the school year about what inverse operations are. We said the opposite of addition is subtraction, the opposite of multiplication is division, the opposite of square rooting a number would be to square it. So inverse operations are basically what one operation does, the other can undo. And this is going to become very important when we're solving those one-step, two-step, and multi-step equations. Our main goal in solving any type of equations is to get the variable alone. I can't stress that anymore. That is what we are trying to get. We're trying to figure out what x is or what w is. We want to know what that value is, and in order for us to do that, we're going to have to get it alone. Now, a rule to kind of help you whenever you're solving one-step equations or multi-step equations is whatever you do to one side, you must do to the other to keep it balanced. Okay, that's why it's considered an equation. It's a balance between the left-hand side and the right-hand side. And we always want to keep it that way. Otherwise, we can't call it an equation because one side would not be equal to the other. Now let's take a look at some of the examples that I have for you. Looking at example number 1, we've got x plus 3 equals 5. Now you might be looking at that and saying, well, that's really easy. We know that x is going to be 2 because 2 plus 3 equals 5. Now, if I asked you to defend your answer in writing, you would still have to be able to show that. And it's very important for us to write down the basics of it, because when we get to multi-step equations, you're going to have to use some of these basic operations to help you with some of the harder parts of it. So let me show you how I want to see your work whenever you're solving any type of equation. With this one-step equation, we know that our variable is x. And attached to that x is an addition of 3. So we're going to use inverse operations in order to get rid of that addition of 3. Now the opposite of addition is subtraction. So what I'm going to do is I'm going to go ahead and subtract 3 on the left-hand side. Now remember that rule of thumb was whatever you do to one side, you have to do to the other to keep it balanced. So since I subtracted 3 on the left-hand side of the equation, I'm going to subtract 3 on the right-hand side of the equation. Now I'm going to kind of draw a line here. Whenever you have a plus 3, if you will, and a minus 3, they end up canceling each other out, and we can show that by just one single slash. I'm then going to bring down x, I'm going to bring down my equal sign, and 5 minus 3 is 2. So now we have proof here, and we're defending our answer by showing our work that x is truly equal to 2. Now you can always double check your work by plugging in your answer where the variable is. You could simply do 2 plus 3 equals 5 to check your work, and you know you have the right answer. All right, let's take a look at example number 2. We have m minus 7 equals 3. The first thing you need to be asking yourself is, what is my variable? In this case, our variable is m. Second question you need to ask yourself, what is attached to the variable? And in this case, it's a minus 7. So in order to get rid of that minus 7, we're going to apply our inverse operations. The opposite of subtracting 7 would be to add 7. So I'm going to add 7 on the left-hand side of the equation. Now whatever you do to the one side, you have to do to the other. So I'm going to go ahead and add 7 on the right-hand side as well. When we have this minus 7 and this plus 7, they end up canceling each other out as 0. We don't need to write 0, we just simply need to bring down m. We're going to bring down our equal sign, and then we have 3 plus 7, which is going to equal 10. And there we've defended our answer by showing our work. And again, we can always check by plugging in, and 10 minus 7 is 3. So we know we have the right answer. And that's kind of the beauty of looking at equations and getting your answer. You can always take what you have and plug it back in. So you should always get the right answer, because if you plug it in and it doesn't work, then you'll just have to rework it, and so that you can have the left-hand side equal to the right-hand side. For example 3, I kind of switched things up on you a little bit. Sometimes the variable is not always on the left-hand side. Sometimes it is located on the right-hand side. So I'm going to show you how we can still solve this problem. I also included decimals in there. We can still solve it, no problem. Now with this problem, again, we want to use the same exact questions that we ask ourselves. What's our variable? Our variable C. What's attached to the C? A minus 7.3. So to undo the subtraction of 7.3, I'm going to add 7.3. And whatever I do to the right-hand side, I'm going to do to the left-hand side. When doing that, I've got 10 plus 7.3. That's going to give me a total of 17.3. I'm going to bring down my equal sign. And then I've got C, and then with that C, our minus 7.3 and our plus 7.3 cancel each other out, so we're just left with that C on the right-hand side. Now, if you don't like how this looks, you can always rewrite it so that C is on the left and you have 17.3 on the right. Whichever way works for you and helps you sleep at night, do that way. And again, it's still considered to be the right answer, whichever way you decide to write it. But we typically see it this way. Now we're getting into some of the tricky equations where we have multiplication and division. In this case, x is our variable, and attached to that x is not just a 2, it's a multiplication of 2. Now to undo a multiplication of 2, we're going to use inverse operations, which would be to divide. So I'm going to divide, and when we show our division, we're going to show it with a bar instead of using this type of symbol. We're no longer going to use that, we're going to use the bar. Now, I've got a multiplication of 2, so to undo that multiplication of 2, I'm going to divide by 2. And whatever I do to the left-hand side, I'm going to do to the right-hand side. Now, 2 divided by 2 gives us 1. And it's almost essentially as if those are canceling out. Now, typically we don't write 1x, we just write x because 1 times x is still x. So we don't usually have the 1 in front as our coefficient. Now I'm going to bring down my equal sign, and 2 can go into 50 25 times. So our answer for this would be x is equal to 25. And again, we can check by plugging in 2 times 25 is equal to 50, so we do have the correct answer. In problem number 5, these can be a little bit tricky because they are involving division, and it's tricky by the sense that students have a hard time sometimes trying to figure out why certain things cancel, so I'm going to try and break it down to you as best as I can. In this equation, we have m as our variable, and attached to that m is a division of 7. Now to undo that division of 7, we're going to multiply by 7. Now when we show this work, we're going to show multiplying by 7 by writing it like this. Now this 7 is technically over 1, if you will. Now if you remember how to multiply fractions, we know that we can cross-simplify wherever we can, and when we do, the 7's cross-simplify because they would turn into 1s essentially, and then we would be left with m. Now again, whatever we do to the left-hand side, we do have to do to the right-hand side, so I'm going to go ahead and multiply this 15 times 7. And 15 times 7 is going to give us 105. So looking at this problem, just to kind of recap, we had our m divided by 7. To undo that division of 7, we had to multiply by 7. Whatever you do to the left-hand side, you got to do to your right-hand side. The 7's ended up canceling, giving us m, and 15 times 7 is 105. Now I want you to take a moment and kind of give problem number 6 a try. I'll give you a chance to pause it, and then you can go ahead and click play when you're ready to check your answer. At this point, you should have your answer for 8 equals w divided by 9. Now to solve this problem, w is our variable, and it's attached by a division of 9. So to undo that division of 9, I'm going to multiply by 9. And I'm going to show that by multiplying by here, and I'm going to also show that by multiplying by 9 here. Now this 9, which is technically over 1, they cancel. I bring down my W, and 9 times 8 is 72. And again, those of you that don't like the variable on the right-hand side, you can always rewrite it to have W equals 72. So this is basically how you solve one-step equations involving addition, subtraction, multiplication, and division. The main rules that you have to realize is whatever you do to the left-hand side, you have to do to the right to keep it balanced. And again, you can always double-check your work by taking your answer for your variable and plugging it back into the equation and checking to see if the left-hand side is equal to the right-hand side. Now, next time I see you, we're just going to do a quick review of this information, and then we're going to get into two-step equations, which aren't bad at all.